So this is our gas cyclometer right here in the X-ray room. So to start, we're going to want to turn it on with this little black switch on the back. So in the computer to run it is right here. There is a small keyboard on the instrument, but it's a lot easier to use the software, which is this one here. So just never bother with the buttons on the instrument itself, please. Then to log into the computer, the password is right down here if you need that. So before we open the software, we want the instrument to initialize first. Okay, so once it displays pressure and temperature right down there, that means we're ready to open the software. Okay, and now it's connected. You can see we have a little schematic that'll pop up right here showing the sample chamber right here and the reference chamber here. So this is our sample here. We have a little small piece of foam. So then we want to weigh that, obviously, so we can get density after we get volume. But to do that, we need to select a sample chamber first. So we have in these wooden boxes a couple different sample chambers. So it says right here all of them. This one is the 10 centimeter cubed. You can see right here is our sample cup for 10 cubic centimeters. And then over here we have inserts for, this is 1 cubic centimeter, I believe, and the other one is 3.5 centimeters cubed is what this one is. Yep. So we want to choose one of those that will best fit our sample, because the accuracy and precision of the machine is based on the total size of the sample container. So we want to fit our sample to the smallest container it can fit in to make our results as reproducible as possible. So we will probably want to use this one. The foam will have to be compressed slightly to fit in there, but as long as we're not trying to measure porosity, that shouldn't affect its absolute density. So when you're using these containers, make sure to wear gloves, because this is very sensitive to other vapors. Finger oil might produce some vapor as well as water. You need to make sure your sample is as dry as possible to make your results reproducible. So we have an analytical balance over here. And just measure our sample right in there. 0.115 grams. So we'll just slip it into our chosen insert here. Put the cap on. And then we'll open the sample chamber. This just spins out. Make sure to set it like so that you don't get anything collecting on the O-ring, because that seal needs to remain secure. Then slide your sample insert down there, insert it in, and twist to lock it in. So now we can go to File and hit New Sample to create a new sample file. We can also do this just by clicking Unit 1, Sample Analysis, and hitting New. So this will open a new sample file. We go ahead and name our sample, foam, operator, and we'll enter our sample mass here, 0.115. Generally, whatever kind of sample you have that will fit in the chambers should probably be fine with the machine. So analysis conditions will generally be fine for any test that you're running. Generally 10 purges up to this fill pressure, 10 cycles. And run position, this is just going to have it terminate after 5 cycles if all of those 5 consecutive cycles are within this precision. So that can help make your test run a little faster instead of having to wait for 10 cycles. So in the report options, there are all these different reports you can use. I'm just going to select a couple of them so you can see how they look. And now hit save as. This will save my sample file. So I'll load it to my file. Give it a quick name. Then I'll just hit close, and you can see right there it's got my sample file in there. So now before I start it, I want to make sure I have the correct chamber insert in here. So I have the insert for 3.5 centimeters. So I need to make sure I hit that, which is very important because otherwise it will put too much gas in thinking that it's still at 10 cubic centimeters. So once I've done that, I can go ahead and hit start. And it will start running, and it will show you what it's doing right here. What it's doing right now is purging, filling this. These will turn green when they're open. You can see now it's venting out, purging the gas inside. And it will run by itself until it finishes. One thing you should be aware of when you do open it, try to keep this closed as often as possible so that moisture can't get inside, because water vapor will screw up the results if it manages to collect inside the chamber. And then temperature also might affect your results. It will tell you the temperature, but room temperature in here is not always very constant, so that is something to be aware of when you're looking at your data. Okay, so once it's done, it's going to give you this export file that'll pop up as well as the report file. So right here you can see it's giving me an error because the measured volume is less than 10% of the cell volume, and that means the results might be inaccurate. Like I was talking about earlier, the precision of your measurement is based on the total size of the cell, so you want your sample to fill it as much as possible. You can see right here it's idle. We're all finished. So we'll go to reports first. You can see here's all the different reports I've selected at the top. We can move between them like different tabs on a browser. I can also select the report I want over here on the side and hit show, and it'll show me that report. Here, density and volume table is just the kind of basic general thing it'll show you. You got your volume here with your standard deviation, then density here, density deviation. This is of course based on the value I provided it, and then the time and temperature it was reading at. So you can see we were pretty stable with our temperature. And then here we have some statistics at the bottom. Average volume 0.087 centimeters cubed with a density of 1.3 grams per centimeter cubed. So you can see we had very little volume because it's a foam and it's mostly air. So even though its envelope volume fills most of the container, it's not easy to read on here because it's so porous. So pressure and volume just shows you the initial pressure, P1, which is the pressure in the sample chamber before it opens up the reference chamber. And then what it will do is it'll open this expansion one here so that the gas can fill the sample chamber and the reference chamber. And then it records the second pressure after that, and it uses these two pressures to capture the volume of your sample. So you can see we also have specific gravity here, which is pretty much just density, but slightly differently presented, and total pore volume at the very bottom here, which you can see is many times the volume of the actual sample. Send volume versus cycle. Let's get our cycle number down here and the volume on a plot. This line here is the average. And density versus time. It's the same idea as a density versus cycle, which we have next, except we switch cycle number out for time. And then options is just going to show you all your sample information and the analysis conditions. And sample log will show you all the errors that might happen. So the measured volume is too low. So then we can print out the reports from here and just use it, print the PDF, but it's easiest. Just go to this export, that'll show up automatically. Hit save as, and now we can choose the file type. We can do a text file, a PDF, an Excel file. We can also save it to their own special file type if we want. So then just hit save. And our data is now saved. If you want, you can get it out of the computer with a USB here. There's no internet on this computer, so you can't email it to yourself. So you have to bring a USB. And you can see, here's our analysis on the sample. So since this saves files as sample files, it's not a method file, you will have to make a new file to do your next sample, even if you're going to use the same parameters. To shut it off, we can just close out of the software. And we're going to want to put everything back. Dispose of your sample however would be relevant for you. Then just put the inserts back where they go. And turn it off. And that's how you run the gas pycnometer.